Greetings, mathematicians. It's time to start our next lesson. We're moving past multiplication with decimals. Now, obviously, we'll still be multiplying. Multiplication's not going anywhere. But as we continue our Module 2 notes, we are going to be focusing a little bit more on division. A little more division. So, Module 2, Lesson 16. We're going to start by using mental math. We're going to use mental math to divide. So let me go ahead and zoom in a little bit. We'll use mental math to divide. Now this is going to start, if it focuses, there we are. This is going to start by looking very similar to what we did with the multiplication. Just obviously we're dividing. Now, let's put our Roman numeral in. We've got a 10, plus 5 more, plus 1 more. There we go. So, Roman numeral 16. Okay. Back to vocabulary. Some of this vocabulary you have heard before, but it's been a while since we've been spending so much time with multiplication. First one, dividend. Dividend. The dividend is a number that is being broken. It's being split up. It's being broken. There we go. A number that is being broken into equal parts / groups. A number that is being broken into equal parts / groups. All right. This is usually the number that you're starting with. It's what you're splitting up into pieces, into groups, into parts, and all those parts have to be equal. Okay. Now the number of parts, the number of groups, is the divisor. The divisor is how many equal parts or groups. It's not telling us how much is in the group. It's just telling us how many groups we're making. Now actually, let me choose my words carefully there. Sometimes it can refer to how many are in the group. The divisor can be flexible that way. Basically, if you start with something, the dividend, and you're splitting it up into equal parts or groups, what you're splitting it into, that's the divisor. Okay, hopefully I didn't overcomplicate that. How many equal parts or groups a number, now I'm just going to put number, but this particular number is the dividend. How many equal parts groups a number is being broken into? Okay. We'll do a few examples in a moment too so we can see those vocab words in action. Number 3, hopefully you remember the quotient. Quotient. This is the answer to a division problem. Now we'll be using the word quotient when we refer to the answer, obviously, but think back to what we've done with equations, making expressions. You may see the quotient of 12 and 4. That means 12 divided by 4. All right, the answer to a division problem. And finally, we're going to be talking more about multiples. Now, multiples, that sounds like multiplication, and it is. Multiplication and division are very closely related. Multiples are the products of a certain number. So the products of a certain number and other factors. So think about if I pick a certain number, let's say 3. The product of 3 and 2. The product of 3 and 5. The product of 3 and 17. Now I jumped around, times 2, times 5, times 17. But essentially, when you're listing multiples, if you're listing all the multiples of a number, which we will do later, you're just thinking about skip counting. I'll go ahead and slide that over so you can see it. Skip counting. Okay. All the multiples of, let's stick with 3. The multiples of 3 are 3, 6, 9, 12, 15, and so on. There are obviously quite a few more than that, but just to get us started. Okay. So there's our vocabulary. Make sure you've got that copied down. We're going to jump down to B. Okay. This is going to be a relatively short section, but what I want to talk about here is a big idea that, again, should look familiar from what we did with multiplication. You can use patterns. You can use patterns and fact families. You can use patterns and fact families to divide mentally. Oof, did not leave enough room for that. There we go. You can use patterns and fact families to divide mentally. This is going to be our letter B. You can use patterns and fact families to divide mentally. Now, slide over here and show you what I mean. Let's start with something that hopefully you're familiar with. 48 divided by 6. If I'm dividing 48 divided by 6, sorry, the light quality keeps changing. I'm trying to make sure it focuses properly. 48 divided by 6. While I was playing with the lighting, hopefully you recognized that that would be 8. Okay. Now, if I multiply the 48 by 10 and add a 0 to it. So this is a multiple of 48, just 10 times bigger. And I divide that by 6. I can use my own rules. Look at the non-zero digits. Go ahead and divide. 48 divided by 6 is 8. I had a 0 here, so I'll put a 0 here. Basically, here's our dividend, 48. If the dividend gets 10 times bigger, but the divisor stays the same, then the quotient is 10 times bigger. Dividend is 10 times bigger, quotient is 10 times bigger. I'm not going to, but I could conceivably do this all day. Let's divide 48,000 divided by 6. 48 divided by 6 is 8. Put the zeros, 1, 2, 3. Now, that seems super easy. And if you have a single-digit divisor, it is. But that's a pretty big if. Use this pattern. Use this pattern for single-digit divisors only. Use this pattern for single-digit divisors only. I'll put a little squiggly underline under single digit. If your divisor is bigger, it's not going to work. So that very much limits how much we can do this, but it's still a nice tool to have. Let's take a look and see how we're going to do it if you have a bigger divisor. Okay. Now, this is still only going to work for multiples of 10. And we mentioned multiples earlier, products of a certain number. So products of 10, things that have been multiplied by 10. Or, in this case, 10 times 10 times 10. Okay. You're looking for things that end in zeros, basically. All right, so what if there is a multi-digit? What if there is a longer divisor with 0 or possibly multiple zeros? What do you do if there's a multi-digit divisor with zeros? Okay. Again, has to have zeros, has to be a multiple of 10. Let's take a peek. Step 1. Step 1. Just like before, box any non-zero digits. Okay. Box any non-zero digits. So we are going to take a look at an example. Let's do 12,000 divided by 300. Okay. Well, non-zero digits, 12, the 1 and the 2 together, that would be non-zero. I don't want to box just the 1, just the 2. I want to put them together as a whole number, especially in a case like this, because I know that I can divide 12 divided by 3 pretty easily. Step 2. Okay, you've boxed everything up that you're going to box up. Now, you are going to divide just, so again, you know this part, just the boxed non-zero digits. Okay. Divide just the boxed non-zero digits. So for my example, I had 12. Now, you don't have to do this every time, obviously. I'm going to put kind of invisible ghost zeros because I want to show that we're not really paying attention to them right now. Obviously, you can just leave it like that normally. But for your notes, if you would, please go ahead and put the little ghost zeros. Here's our other boxed digit. There's a 3. There we are. So, 12,000 divided by 300. 12 divided by 3 is 4. Now, we have all those digits. Multiplication was nice. We just counted them up and tossed them over here. But division's not going to work that way. Division, we are breaking things up. Usually we're making things a little smaller. Now, that's not always going to be true. Decimals and fractions throw a monkey wrench into that. But for today, most of your answers are going to be smaller. So, what we have to do next is cancel out pairs of zeros. Okay. Now, this is the part where I have one of my silly examples. This is where I teach my students your numbers are basically playing Go Fish. So what on earth does that mean? Let's break the pencil and then find out. 12,000 divided by 300 equals 4 something. Okay. Now we had boxed up the 12, we boxed up the 3, that's where the 4 is coming from, so we're good there. What's going to happen is the zeros are going to play Go Fish. And we're going column by column. So this is me talking about place value again. Start in the tens column. Start in the ones column. I guess I'm the one who needs the review. Start in the ones column. So the ones column says to the other ones column, got any zeros? Yep. So they make a pair. Now I look in the tens column. See, I was getting ahead of myself. Look in the tens column. Look in the tens column. More zeros. Okay. But can I make a pair in the hundreds? No. No more zeros. Okay. Go column by column. If you're on graph paper, this is nice and easy to see. If you're not, just think place value and take a look. Do it the way that I did it. once we've canceled out these zeros, and I don't want to get into a bunch of stuff, but basically this is, if I have two zeros, this is like 100 divided by 100, right? 100 has two zeros. 100 divided by 100, it's going to be 1. So it's not going to change my answer. It doesn't need to be anywhere. Okay. Now, whoops. Boy, see, I'm getting ahead of myself again. I guess this is just so exciting. For step 4, let's make sure I write that correctly. Step 4, put any remaining zeros in the quotient. Now I canceled out every pair of zeros that I could make. So, on my very last line of the paper, we're almost there. 12,000 divided by 300. 12 divided by 3 was 4. This ones place says that doesn't matter which direction you go. Ones and ones, done. Tens and tens, cross them out again. Hundreds and nope, can't do anything there. So that 0 gets to join the 4 in the quotient, and that will be our answer. 12,000 divided by 300 equals 40. As always, we'll do more examples in class. This was very stretched out because I wanted you to see each piece and have the instructions for each piece so that you can look back at your notes later. But really, once you get the hang of this and you start doing it, it goes very, very quickly. You're not going to write, obviously, every single one of these lines. You're going to write this. This is what your work will look like down here at the bottom. All right, we'll go ahead and wrap up for this lesson. As always, if you have any questions, please make sure you bring them to class, and I will see you there. Thank you, ladies and gentlemen.